All right, so Chem 30, we are basically towards the end of acids and bases. So far, we've gone through a lot of stuff, and we've really been talking a lot about how when we have water, we can put an acid in the water, put a base in the water, but water has its own equilibrium system. Remember, water reacts with itself to make H3O plus and OH minus. And that equilibrium is adjusted and affected by adding an acid or adding a base. Add an acid, you shift equilibrium. When you add a base, you shift that water equilibrium. And that water equilibrium connects all of this together. And that's what we're going to take a look at today, is how we can actually use that. When you're dealing with acids and bases, you should be able to calculate pretty much everything. That means you should be able to calculate concentration of H3O plus, concentration of OH minus, pH and pOH of any acid or base, whether it's strong or whether it's weak. And so what I wanted to show you today is something that I call the acids and bases roadmap. And it's a way to help you be able to solve acid and base problems and figure out everything that you need to about that solution. Okay, so let's go into the camera. Okay, like I said, I'm going to introduce you to the acids and bases roadmap. And so, like any roadmap, we should think about, where are we starting? Anytime you're given any question, what you really want to think about is what is the starting point? And a lot of the time, that starting point is either going to be some kind of acid, or it's going to be some kind of base. But remember, there's not just one kind of acid or one kind of base. There is strong acids. There are weak acids. There are strong bases. And there are weak bases. And as we saw like 56 videos previously, I know it's been a while, but these determine how you're actually going to be starting. And to me, these are like your starting points on the roadmap. They determine what you're actually going to be able to solve. If you're dealing with an acid, the easiest thing that you're going to be able to solve for is the concentration of H3O plus. Depending on if you are using a strong acid or a weak acid, there's a different way to get there. Strong acids use remember, use stoichiometry because it's a one-way reaction. There is no equilibrium. A weak acid, on the other hand, has equilibrium, and remember that means you need to use the Ka to solve that. Now we can solve the H3O plus if we're dealing with an acid, but if we're dealing with a base, you can't jump right there. Instead, what you need to be able to solve is the concentration of OH minus. And again, it's going to depend on, do you have a strong base or do you have a weak base? A weak base is in equilibrium, but it does not have a Ka, it has a Kb. Remember, the equilibrium constant of a base. A strong base, on the other hand, though, strong stoic, you can use stoichiometry to deal with a strong base. That's our starting point. That's how we enter the road. You have to enter depending on where you're starting from. Do you have a strong base? Or do you have a strong acid? Do you have a weak base? Do you have a weak acid? Figure that out first. Once you know that, then you can start doing some calculations. Let's say I wanted to know the concentration of OH minus, and I know the concentration of H3O plus. I can figure this out because I can relate this using the Kw, right? Remember, the concentration of OH minus is going to be the Kw divided by the concentration of H3O plus. I wrote that about as small as I could. Okay? But what if I know the concentration of OH minus and I want to know the concentration of H3O plus? Well, the concentration of H3O plus is going to be the Kw divided by the concentration of OH minus. So I can move back and forth in between those two. And it's all related because of the Kw. Kw is the concentration of H3O plus multiplied by the concentration of OH minus, and it has a numerical value of 1.0 times 10 to the minus 14. Okay, but remember there's actually more things that we can solve about a solution. Maybe we want to know the pH. Well, luckily I can go from the H3O plus concentration to the pH. How do I do that? Well, remember, the pH is the negative log of the concentration of H3O plus. But what if I know the pH and I wanted to go backwards and go and find the H3O plus concentration? Well, the concentration of H3O plus is 10 to the power of the negative pH. So now I can go from there to there. Okay, but that's not the only thing we can solve. Remember, there is also the pOH. So let's say I know the concentration of OH minus, and I want to be able to solve the concentration, or the pOH, sorry. Well, the pOH is the negative log of the concentration of OH minus. And what if I know the pOH and I wanted to be able to solve the concentration of OH minus? Well, remember the concentration of OH minus is going to be 10 to the negative pOH. Pretty good, hey? So now we know, let's say we're starting anywhere, we can get to a starting point into the map, and now we can start working our way around. But we're not finished yet, because if I know the pH, I can find the pOH. And if I know the pOH, I can find the pH. And how can I do this? Well, the pH in a solution added to the pOH in a solution is equal to 14. And there it is. The acids and bases roadmap. If you know a starting point and you know what kind of substance you're dealing with, you can then solve everything about that substance. It doesn't matter what it is. And so that's going to be our next step. Let's work through an example and let's solve everything we can about that solution.